Now you can see that this is one more problem where a series RLC circuit has been given for us. It consists of resistance of 12 ohms, inductance of 150 millihenry, and capacitor of 100 microfarads. It is very similar to the one which we already completed in the last video. These elements are connected in series with a 100 volts 50 Hz supply. So determine impedance, circuit current, power factor, and the voltage phasor diagram. Now let's try this one. See, first of all, let's start writing draw the figure, inductor and a capacitor. Right, so let's list the values now. See, this is an RLC series circuit. These are the resistance, inductance and capacitance. The values are 12 ohms, 100 microfarads and 150 millihenry. Okay. So this is 150 millihenry, right? Now the supply voltage is 100 volts, whereas the frequency is 50 Hz, which means we will be getting our omega value of 2 pi f, which is nothing but 314.15. Now let's try to determine the first one, which we call it as an impedance. So before we go with the impedance. See, this is R, this is L, this is C, and we have know that Z is equal to R plus J into XL minus XC, where XL is omega L minus 1 by omega C. You know the values of R, 12 plus J, 314.15 into L is 150 millihenry, which results in 0.15 minus 1 by 314.15 into 100 into 10 to the power of minus 4. If you solve that, you will get a value that I will show you here. See, what is the value? 12 plus J, 15.29 ohms. This is your impedance in rectangular form. You can convert it into polar form now. Okay. Now the circuit current, magnitude and also the phase angle. Now I is equal to V by Z. V you do have it already. It is 100 at an angle of 0. By Z is 12 plus J 15.29. Okay. So now convert this one into a polar quantity and you will get a phase angle and also a magnitude. Okay. So this is your value which I have converted into its polar form. It is 19.43 at an angle of minus 51.87. Now the magnitudes are to be divided and the angle is 0 minus 51.87. Now this division gives me a 5.146 and this one gives me 51.87 because this is my I of I. So this is the magnitude 5.146 and this is my angle. Okay. Yeah, sorry, I think it is plus here. This is plus and here I'll be getting a minus. Okay. So a small correction here. So this is my current magnitude and also the phase angle. Now if I move on to the next one, the power factor. V is equal to 100 at an angle of 0, whereas current is, we have obtained as 5.146. It was 5.146 at an angle of minus 51.87. When compared to the voltage, the current is lagging. Okay, so I will be getting a power factor which is defaultly lagging. And the value is cos of angle of voltage minus angle of current. Whatever the angle which I will be getting, cos of 0 minus of minus 51.87, I will be getting 0.616 and it is considered as lagging. Okay, so power factor is also completed. If you want to compute active power, VI cos phi, right? If you want to compute reactive power, Q VI sin phi. Okay, this is 100 into 5.146 into the power factor 0.617. This is 100 into 5.146 into, this is cos phi, so you should calculate sin phi and you should write it down. Okay. And next is the voltage phasor diagram. But before we go with the voltage phasor diagram, let's try to compute the, see, this is your RLC circuit, right? I do have my voltage across the supply. It is 100 at an angle of 0. Now voltage across resistor is I into R. I was, I think it was 5.146. It's an angle of minus 51.7. Into R value is 12 ohms. If nothing is there, it is 12. So if I multiply, I'll be getting a value, right? Similarly, VL. What is VL? I into J omega L. This is again 5.146 at an angle of minus 51.87 into, this is the magnitude omega L. So omega L is 314.15 into 0.15. Angle is, since J is there, I'll be getting 90 degrees. Now this is how you do. Next is VC. It is I into minus J by omega C. Right, this is my current, and this is 1 by 314.15 into 100 into 10 to the power of minus 6. Now the angle for this one is, since it is minus J, I'll be getting minus 90. So I'll be getting the values if I calculate these things. See, this is my voltage across resistance, this is across my inductance, and this is across my capacitance. Right. So now once I do get these values, I should draw the voltage phasor diagram. So I am taking VR as a common thing. Okay, VR is taken as 62. See, and let me write the things for you. See, this is your my VR was 61.752 at an angle of minus 51.87, and my VL was 242.47 at an angle of 38.13, and my VC was at 163.79 at an angle of 141.87. Right, these voltages you should pen down now, and my total VS was at 100 at an angle of 0. So which one you want to take as a phasor, as a reference, it is your choice. If I want to take VS as a phasor, so this is my VS. VR, since it is at an angle of minus 51, I'll get VR like this, and VL will be at 38.17. So from VR, I'll draw it at 38.17. And VC, again, I have to come back from here. Okay. So otherwise, I'll take this one as 0. This is the reference one. So if I take this one as 0, means I have to add 51.87 for each of these things. Right. So this will become 90. This will become, if I add 51, this will become 180. Isn't it? Am I clear? If I add 51.87 for each of these things, so this will become 0, this will become 90, and I think this will become, 1 minute, let me check. Yeah, I think it was minus, right? So, yeah. So this is minus, so this will become minus 90. Yeah. So now I'll take VR as a 0. And from here, if I draw VL, this is my VL, because it is at 90 degrees, and again minus 90, which means it must be in bottom direction. So again from this point I should draw a backward value. This is VC and this was VL. So if I join the final value, then I'll be getting my VS. Understand? So this is how we draw the phasor diagrams. Okay. So hope you have understood it. Practice all the problems and come back to the class. Now this is your homework problem. Try to practice it at home and come back, and we will clear any doubts which you do have.